Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about how Venus got its ugly, ugly face. Good thing it has all those clouds to cover it up. And if I have time, you're never going to live on Mars. And of course, taking listener questions about all things in the universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern. So call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about Buy My Book. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, chief scientist at COSI. For the next half hour, your agent to the stars. Got an exciting show for you today where we talk about all the glorious things in our big, bad universe. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern here in Studio A of WCBE Radio Columbus. Call 888-581-0708. You can also follow along on the live streams on YouTube and Twitch. Join those space cadets tuning in live right now from Guildford, Surrey, UK, Vipava, Slovenia, Texas Hill Country, Austin, Texas, Hutto, Texas, big representation, Boulder, Colorado, Kempen, Montélimar, France, and Brandywine, Maryland. Wow. All sorts of places. Love it. Love all the space cadets tuning in, and you can join them. Go to spaceradioshow.com for the links. Seriously, folks, I prepped 10 minutes of show material top, so get those questions in. Is it Brandywine, Maryland? It is Brandywine, Maryland. I thought I wrote it down wrong. And I questioned myself. Thunderduck, I will answer your question at the end of the show about my book, which was right here. Oh man, I gotta figure out a new table for the book to prop it up. Right now it's just a cardboard box that is very unstable. And right before we went live, I elbowed it right next. Oh man, it was embarrassing. How unprofessional. And I see lots of good questions coming up. Nancy Graziano, as always, big help. She's collecting those questions for me and putting them on the Slack channel for me so I can read them and I can keep track. Tons of great questions. Love it. Keep the questions coming as I talk about the news. Before I start taking questions, I wanted to share some interesting bits of news I caught recently. And something that really, really hit me in the face is a story about the face of Venus. You know, we think of Venus, if you just look at it with the telescope, it's just blah. It's shiny, which I guess is nice, but it's clouds. It's like 15 miles worth of thick, choking, poisonous carbon dioxide atmosphere, one of the most extreme environments in the solar system. I would say it's more extreme than Mercury. I would say Venus is more extreme than Mercury. Mercury is just a boring, dumb rock, and no offense to all the Mercury missions ongoing right now, but it's just a boring, dumb rock. Venus is also a boring, dumb rock, but it also has a thick atmosphere, which makes it slightly more interesting. The surface is hotter than the surface of Mercury. It is covered with volcanoes, and not just little volcanoes like a Mauna Kea or a Mount St. Helens or a Krakatoa. That's peanuts compared to the volcanoes of Venus. The volcanoes of Venus are hundreds of miles wide, are so big that they depress the crust underneath them. So they're actually not very tall because they push down on the planet itself. They sink into the planet. And there's evidence of a ridiculous amount of volcanic activity on the surface of Venus that shut off 100 million years or so ago. So like yesterday, in astronomical terms, Venus shut off. There may have been some light volcanic activity as early as 2.5 million years ago. There doesn't appear to be active volcanism on Venus right now, although that's a little bit hard to tell because of, the really thick clouds. And there's this question, because of the constant volcanic activity, Venus has a very young face. It's one of the few bodies in the solar system that has refreshed its face. It's not all pockmarked. It's not full of craters like the moon or Mercury. It's smooth. It's smoother. It's younger. It's fresher. It's also kind of ugly because, all the giant volcanoes, but at least it's youthful. And what made that? There's a bunch of competing models. It could be like the constant volcanism, but then you have questions about timescales and how quickly the entire surface can churn over. There is a popular theory where the entire crust in one relatively short-lived event, probably as Venus started to cool off, the entire crust shrank and subducted underneath the surface and shrank down into the core and was like flipped over. Can you imagine the entire surface of a planet just cracking and flipping itself over? Neither can I, because that's pretty awesome. That's in this model is called into question with some new research published in the Journal of Geophysical Research, where they call into question this model, and they're not exactly sure what has caused the resurfacing of Venus, but based on computer simulations and timescales of this kind of titanic activity, they don't think it quite matches up with the evidence presented by Venus itself of where its center of mass is, how young the surface is, where some of the features on the surface doesn't quite add up. It doesn't complete the story. We don't exactly know how Venus got such a young face, but the most popular theory out there is called into question. That is the latest and greatest when it comes to space, but it's time to have a conversation. Where do I start first? Ooh, I love this question from Flip Flops on YouTube about the James Webb. All right. And Thunderduck, I'll answer about your question about Venus. And if I have time in this segment, Adam, I'll get to your quick question about favorite next-gen telescope. We've got questions rolling in on the live streams. First up, YouTube flip-flops. No, before I get to flip-flops, I want to talk to Thunderduck. Love these YouTube handles. Thunderduck is asking about the magnetic field of Venus. So the Earth has this tremendously strong magnetic field, far, far stronger than any of the rocky planets. Mercury has this tiny, tiny, tiny magnetic field. Like I said, it's just a dumb rock. Mars has a very weak magnetic field, barely there. Venus is interesting. Venus is very close to the same size as the Earth. Very similar formation history, very similar distance from the sun. If anything, if you had to pick an Earth 2.0 candidate, if you rewound the clock 4 billion years ago to the formation of our solar system, and you had to guess where Earth 2.0 would be, you wouldn't look at Mars because you immediately see that thing's way too small. It's not going anywhere. But you would look at Venus. Because it's very similar size. But Venus is radically different from the Earth. One, it has this super thick atmosphere. And two, even though it's the same size, it looks like it's cooled off. In space, it takes a long time to cool things off, especially if you're big. So the Earth's core is still very, very warm. The Earth's core is warm from two things. One is from the formation of the planet itself that released a lot of energy, and it takes a lot of time for that energy to bleed off into glowing infrared radiation into space. And two, we have a bunch of radioactive elements inside the core that are radioactively decaying, as radioactive elements are wont to do, and that releases heat and that keeps the core warm. So we have a really warm core. We have a lot of iron and nickel in our core. It's constantly mixed up. That provides the dynamo mechanism to generate the Earth's big magnetic field. So you look at Venus, which is also large, presumably also has a lot of radioactive elements, and appears to have a stone cold heart. It looks like in the past Venus had plate tectonics, active volcanoes, the whole deal, but not anymore. And it shut off relatively recently. Why is Venus different than Mars? That is an honest question. That is it. I'll throw that out to the audience. If you have any ideas, 888-581-0708. I'd love to hear your ideas of why Venus is so different from Earth, even though they started off as essentially twins. We don't have much. We don't have much. Venus is not a very well explored planet. Unlike some other planets, looking at you, Mars, that happen to hog all the attention, we don't send a lot of spacecraft to Venus. We don't understand a lot about Venus. And honestly, when it comes to Mars, studying Mars in the early days of Mars is very interesting from understanding the early history of life on Earth, because Mars had liquid water oceans and rivers and streams and blue skies and all that. And so it was very Earth-like in the early days. Venus was very Earth-like in the early days too, and took a completely different track than either Mars or Earth. Did Venus ever have life? We don't know. Doesn't seem likely. Does Venus have life now? Most likely not, because of the extremely high temperatures. What made Venus shut off? And Thunderduck follows up on YouTube with a very, very good point. When the dinosaurs were around 60 million years ago, Mars was already dead. But Venus was still warm. Venus still had volcanoes and plate tectonics, the whole deal. 65 million years ago, 100 million years ago, Venus was more like Earth than Mars was. Why is it different? We don't know. There's so many mysteries right in our backyard. Isn't that? I don't know. I love that kind of stuff. Anyway, getting to the other question from Flip Flops here, also on YouTube, one of the space cadets, asking about future missions and especially the James Webb Space Telescope, asking what will it tell us? Like go past the launch, go past 50 years after the launch of James Webb, will it be as remarkable? Will it be as historic as something like the Hubble? Because the James Webb is built up to be the successor to the Hubble Space Telescope. And it's going to be a big giant telescope, the biggest one we've put in space. It's going to be a big deal. There's going to be a lot of scientific return from it. Will it be as groundbreaking as the Hubble was? Will we look back on a multi-decade career and realize what this amazing instrument was? And in 50 years, will we be saying, we need to put up the James Webb 2? We need to put more. We need 20 James Webbs to look at all that science. The exact same discussions we're having about the Hubble. I will answer that question as soon as we come back from the break. I'm Paul Sutter, and this is Space Radio, and this show is brought to you by you. Go to patreon.com/PMSutter. You and you alone hold the future of this show in your hands. Patreon.com/PMSutter, and I'll see you after the break. Good point, Thunderduck. I love that action in little commentary that 100 years ago, Venus was more Earth-like than Mars was. And thank you very much, Nancy, for collecting these questions. Alexander Kreisel, and then I'll get to your question, and then Flip Flops. Lots of topics for this. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet listener questions ready to go, but you can join the conversation by calling 888-581-0708 or by joining the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. Now, I teased before the break, question from Flip Flops, one of the space cadets on YouTube, asking about the legacy of James Webb. I really do think James Webb Space Telescope, if it ever launches, will actually be a fantastic instrument. Will it have the same legacy as Hubble? That's hard to say because we don't know what we're going to see. We have mission designs and mission targets, and we have an idea of what we want to go out and look for. But until you actually open your eyes and look, you can't say what you're going to discover. That is like the whole point of discovery. And so, will James Webb be as groundbreaking as the Hubble? Maybe. Good shot. Will it be something that's very important scientifically but doesn't capture the public imagination? Maybe, maybe not. The James Webb will not deliver the pretty pictures of the Hubble. It is a much more powerful telescope, much more sophisticated, but it is not designed to take pretty pictures like the Hubble. James Webb is an infrared telescope primarily. It does see a little bit of visible light, but mostly infrared. And so, yeah, we can take those infrared images and we can slap some fake colors on them to represent like intensity or wavelength or blah, 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 blah. And you will get pretty pictures at James Webb, trust me. But its primary mission will not be pretty pictures. Those pretty pictures developed by Hubble are scientifically useful, which is why we make them. They are also great PR, which is why we make them. James Webb will make pretty pictures, I guarantee it, but not in the abundance of Hubble. James Webb is going to look at faraway things. James Webb is going to look at small things. James Webb is going to look at stuff that's difficult to see. And when you're looking at stuff that's difficult to see, you're not going to get the pretty pictures that you're used to. What will James Webb look at, and why is it infrared? Well, we're looking at when planets form. We're looking at young systems. We're looking at the atmospheres of planets orbiting other stars, looking at signs of life. We're looking at the first generations of stars and galaxies to ever form in our universe. It could be that we unlock some mystery of what we call the dark ages of the universe, when the first stars awoke in an event we call the cosmic dawn 13.5 billion years ago. There might be some stunning revelation that will shock the world, and James Webb will cement its place in history. It might pick up the signature of, say, oxygen in the atmosphere of a planet orbiting another star, a sign of life. That will certainly be big headline news. It might catch something unexpected about the formation of planets around young stars. Or maybe not. Maybe our searches come up empty. Maybe what we observe when it comes to the first stars is exactly in line with expectations. It's just verifying something we theorized about 20 years ago. Maybe it comes up with more questions than answers. Maybe it will be useful and important, but won't capture the public imagination. Maybe, but we're not going to find out until we actually get up there and start taking some pictures. Now, related to that, we had another question from Adam Synergy, one of the space cadets on YouTube, asking about all the next generation telescopes like HabEx, Lynx, Origins, LUVOIR, all these proposed missions. So what's going on here is there is a program by NASA to send a spacecraft and observe almost every single frequency of radiation. So, okay, infrared, boom, we're going to have an infrared telescope. X-ray, boom, we're going to have an X-ray telescope. Optical, visible, we're going to have an optical and visible telescope. Boom, 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 all the way down the electromagnetic spectrum. Those instruments are kind of getting old, a little bit long in the tooth, you might say, and it's time for an upgrade. And all the focus is on James Webb, which is the replacement for the Hubble, mostly in infrared though. But there's a bunch of others. What about the gamma rays, man? What about the X-rays? What about microwaves? Like, hey, let's not forget about the rest of the electromagnetic spectrum. And all these missions are going to be vital, very useful. We need these missions to go so we can get a complete and total census, a picture of the night sky in every wavelength. As to a favorite, I honestly don't have a favorite because I think we need them all. I'm not biased or prejudiced when it comes to my radiation preferences. I like it all, and they all play off each other, and they're going to play off. This is what's really cool. They're going to play off things like gravitational wave observatories and neutrino observatories, where we're unlocking the power of having different kinds of eyes and ears and noses, looking at the night sky in different kinds of ways and putting together a complete picture so that we can unlock this really big, messy place that we call the universe. Oh, I need to pause, Greg, because there was another question and I lost it because there's so many good questions. Okay. Going back to Venus and the formation of the solar system, I mentioned in the early beginning of the episode that one of the reasons Earth is warm is that we have all these radioactive elements, and these radioactive elements are decaying, and that helps keep the core of the Earth very, very warm. And one of the space cadets, Morton Anderson, asks, where do these radioactive isotopes come from? Shouldn't they have degraded by now? Why should they still be here? And the radioactive elements came with the Earth itself. If you want to make a planet, if you've got a big old nebula and you're going to make a solar system, you're going to make some planets, it's a package deal. You get all the elements. You want to build, something out of carbon and oxygen and silicon and hydrogen, and you want to build a planet. Well, you're also going to get some plutonium and some uranium and some technetium and some things that you'd probably not have along for the ride. But guess what? It's a buy one, get all. You have to get the whole package when you build a planet. So when our solar system was formed, it was already laced with these radioactive materials, and they are embedded in the Earth itself. Sometimes chunks of these radioactive materials come up close to the surface, and then we can dig them out and use them for various interesting purposes. Most of them are buried deep, deep in our core. Why haven't they exhausted yet? Well, some radioactive elements have very short half-lives, tens of thousands of years, and so they go away. But some of them have half-lives of very, very long times. And even if they have a relatively short half-life, if you have significant amounts of these radioactive elements, then they'll still hang on 4.5 billion years later. And it's about half the heat. About half the heat in our core is due to the radioactive decay of primordial elements that were here when the Earth formed. So the next time you see a volcano, or the next time you see the continent shift, that isn't really something you watch in real time, but the next time you think about it, you can thank radioactive decay. Thank you so much for all those amazing questions today. Unfortunately, we're almost out of time, but before we go, it's time for the blue shift. Yeah, sorry, Nancy, Nightbot. I can only enable Nightbot on one channel at a time, YouTube or Twitch, and I picked YouTube because I did. Larry asking about Samir Mathur's model, a model with no firewall. Samir actually has an office down the hall from me at Ohio State, and I've been meaning to catch him in the hallway and have him explain that paper to me directly. Maybe I'll bring him on as a guest to Space Radio. That'd actually be really fun. Raj, I would love to answer your question about an accurate calendar. Ask that again next week, because I think that'd be a really fun question next week. In SAHM, is math related to science? So science uses math. Mathematics is a backbone of science. Science use math for two things. One is to enforce logical consistency so that we can make a statement and then we can derive conclusions from that statement that we know are 100% logically sound. So you don't get any of that wishy-washiness that you might get in, say, philosophy. Nothing against philosophy, but this is one of the pitfalls of using a natural language, is that to connect statement A to statement B, you'd like to make sure there's a 100% airtight connection. Mathematics allows you to make a 100% airtight connection so that you can work backwards so that you can go out, make predictions, and then test the predictions. And then if the predictions are revealed to be correct, then you know your base hypotheses are also correct. So it allows that connection. And we also use mathematics to just make nice short statements about the world. Like you could describe electromagnetic radiation using just words and throw in a bunch of jargon and how they relate and how it changes with time, or you can just write down 4 equations and be done with it. And it perfectly 100% encapsulates all that all what you want to describe about nature. So mathematics is a background for science. It is not science. Mathematics is its own thing. Very proud profession. Lots of cool mathematicians out there doing very cool, useful stuff. They do mathematics for the sake of mathematics, exploring these very complex, intricate, logical structures. Scientists, when we need to do something like describe how the universe works, we start looking around if the mathematicians have played with anything useful recently, and we say, here we go. Here's a certain mathematical structure that perfectly encapsulates and summarizes and describes what I'm trying to, describe nature with. I'll use that. I'll borrow, thanks, mathematicians. I got it from here. And then the physicists use it. Sometimes physicists develop our own toolkits. Paul Dirac was famous for this, of just making stuff up as it went along. And then later the mathematicians would say, oh yeah, I guess you uncovered a whole new branch of mathematics. And so, yeah, nothing against philosophy, nothing against math, but it's almost like when you take philosophy and math together, that is physics and that is science. All right, I gotta do the blue shift. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift. And by the way, if you don't catch the live streams, if you're just listening to this on the radio, I do a lot more interactions with the Space Cadets, with the live streamers. I answer more questions. I have more conversations that don't make it on the air. There's a little bit of value add. So you can either watch it live, in which case you can contribute your own to the conversation. That's at Thursdays at 4 p.m. Or you can catch the videos on YouTube and Twitch. Just go to spaceradioshow.com and there'll be links to where you can see the show on YouTube and Twitch. So I'm just saying you're kind of missing out on a little bit of a space party every single week. Speaking of space parties, I wrote a book. It happened. I wrote a book. It's called Your Place in the Universe, Understanding Our Big Messy Existence. It's being published by Prometheus, wonderful publishers, great people to work with. It will be in stores nationwide, Barnes & Noble, Amazon, Books A Million, IndieBound, the whole deal. And you can get it off my website. You can go to pmsutter.com/book to kind of tease you the contents of the book, as if the title didn't already entice you. Here are the chapter titles. For my book. Are you ready? Starting with Prologue. Perhaps this was all a big misunderstanding. Chapter 1, Sacred Geometry. 2, A Broken Universe. 3, Tales from a Bewildering Sky. 4, The Death of Antimatter. 5, Beyond the Horizon. 6, Bathed in Radiance. 7, Reaping the Quantum Whirlwind. Interlude, A Guide to Living in an Expanding Universe. 8, Behold the Cosmic Dawn. 9, Of Matters Dark and Cold. 10, The Cosmic Web. 11, The Rise of Dark Energy. 12, The Stelliferous Era. 13, The Fall of Light. 14, The Long Winter. Epilogue, A Game of Chance. This was quite an experience of a book to write, and now I'm actually reading it because we're going through the whole copy editing thing right now. It is available for pre-order. You can get a copy right now, pmsutter.com/book. And we had some questions from the Space Cadets asking, are there any events for book signing, for live, for the whole deal? Yes, I am in the middle of arranging a book tour. Go to pmsutter.com. There are already a bunch of events centered on Central Ohio, branching out to Cincinnati, Dayton, Cleveland, Pittsburgh, and more already on the books. All that calendar is at pmsutter.com/book. There are plans afoot to come to your city, wherever your city might be, to do live events, to do a speaking thing, to sign some books, to have another in-person space party, because we could all use an excuse for a party about space. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. This show is also brought to you by you. Go to patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. You can call 888-581-0708 to join the conversation, or the Space Cadets over on YouTube and Twitch. Go to spaceradioshow.com for the links. You can also follow me directly on social media. My name is at Paul Matt Sutter on all the channels. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Yes, Thunderduck, I'm actually in talks right now to be at least at Fort Worth and Dallas for a book signing event. I understand that Texas is a rather large state, so you may not be able to make it to Fort Worth or Dallas, but I do have plans to visit other cities, but those are still pending. And yes, John Michael Gaudier, this looks like nothing, right? That looks like a skinny book. This looks like an afternoon and evening read. It was one of the most painful experiences I've ever had. And it's just rough. It's just so hard to write a book. I don't know why no one told me. Everyone's like, Paul, you should write a book. Paul, you should write a book. Publishers and agents are like, Paul, you should write a book. I'm like, okay, I'll write a book. I mean, I write articles for space.com. I write show notes all the time. No. Oh my gosh. This was my entire fall last year, from late August to February. This was my life. Nancy, yes, there are plans afoot in New York, especially December 1st. December 1st, I'll be in Manhattan for at least a couple events. Yeah, John, just showing up to do a radio show, this is like crackers. It's so easy. This was just my life. I mean, I should interview my wife about what was it like for your husband to write a book, because she will tell you it is every conversation for 6 months ended with, I gotta go write. I gotta go write. I'm trying to get this chapter done, and I gotta go write. Everything for like 6 months. Paul Christian, come to Eastern Europe. Hey, I was just in Ukraine a few weeks ago. That's very Eastern Europe. But no, I don't know if I can put together a worldwide book tour. It's going to be the U.S., Central. It's going to be Midwest, starting in the Midwest, then going out to Texas, Florida, California, New York. I would love to do stuff in Europe too. And I have contacts out there, but it's a little bit more complicated with the publishing world. But I will try to put something together to make this a worldwide book tour. And Greg Moebius will come with me as my assistant. But we'll put him in coach. Show title, yeah. Paul wrote a book. I like that. Very nice and direct, Nancy. Your place in the universe. Understanding our big messy exists. By the way, streamers, space cadets, my title for the book, was You Are Not Special. Our universe and your place in it. The publisher thought, or Barnes & Noble thought that was a little too sarcastic. 90% of this book is sarcasm. You can flip to a random page, and I guarantee. Yep, sarcasm right there. Sure. Fine. We're going to let people judge a book by its cover. You can come in, Greg, don't worry.
So promo?
Oh, yeah, you want to record a promo?
Yeah. Remember to come back at the end and say, and that's Space Radio.
Yep.
Saturday at 2.
Yep. Yeah, John, I'd appreciate an email. What happened to Venus? Why is it so dead and why is it so hot? That's an honest question because we actually don't know, but we will explore the mysteries in today's space radio. It's not today, is it? No, dang it. It's Saturdays. Why is Venus so hot and so dead? We don't know. It's actually kind of an open question, but we will explore the mysteries in the next Space Radio. That's Saturday, 2 p.m. I'm Paul Sutter, the host, and it's a really good time exploring the mysteries of that dead hot planet. WCBE 90.5 FM. Does that work? Okay. Good enough for public radio is our motto here. Adam, you can, oh, I love that. Host the, and a cuppa with each copy. Why is what upside down? My book? Was I holding it upside down? Oh, why is Venus? No, why is it? I didn't even get to that. Launchpad Astronomy. Oh, man. Come back next week and ask that question because I didn't even get into that. Like, why is Venus going backwards? It's just, gosh, what a messed up planet. I feel bad for it. Yeah, Nat Fan. Well, here's the thing. I wrote a pitch for the book, outlining the chapters, what my platform, how I'd promote it and advertise. And it was like sarcasm, end to end. And then they came back to my agent and they said, we love his tone. We love, his style. It's really fun. And so they were on board. But Barnes and Noble thought the cover was too sarcastic. It was Barnes and Noble's fault. So don't blame my publisher. Don't blame Prometheus. But I get it. People do judge books by their cover. They wanted a big science word in the cover. They wanted the word universe in the title. They wanted a pretty picture. Like, I get it. We got to sell books. What matters is what's inside the pages. So if this can sell more books than my title, I'm all right with it. And then you open it up and you go, what have I done? I've just wasted $24. But I'm a completionist, so I might as well finish the thing. And then you'll learn something about astronomy. That's the plan. All right, Launchpad Astronomy, come back next week. We'll talk more about Venus. I will see everyone next week. Thank you so much for all the great questions, and thank you, Nancy, for all the assistant